Hey guys, today we're going to talk about more parametric equations, but what we're going to be doing tonight is parametric equation, but this is going to be called projectile motion. So this is classic physics problems. This is the problems where they're shooting a cannonball or there's throwing a baseball, shooting a rocket, all these type of problems. These are called projectile motion. So let's get started. So the projectile motion has a formula that we're going to need. Actually, two formulas you're going to need to know. So starting off, projectile motion. Well, let's think about this first. So we have velocity vector. So I'm going to call this a velocity vector. And what's going to happen is this. So we're going to call this velocity vector v. So picture this scene. There's the ground, right? There's the ground. Let's say we're throwing a ball, and the ball's going to go up. Now, what happens when you throw a ball? It's going to go up, it arcs, and then it hits the ground. So what's going to happen is we're going to write equations to model this throwing of the ball. So let's start off. So we have vector v, and we can break this down like we've been doing in class. We use this formula, the magnitude of v times cosine theta, and the magnitude of v sine theta. So it's going to be based off of, to start with, we're going to be based off of this. The cosine is the x part, the sine is the y part. Cosine is x, sine is y. And instead of v, we're going to call it v sub 0 or v initial. This is initial velocity. So this is the initial velocity. So what's going to happen is, just change color here. So we got this ball. So we have a height off the ground, right? This height off the ground is our initial y value. So we're going to call this y0, which means y initial. This vector, we're going to throw it at this angle, whatever this angle is. This is going to be our v0. Now what happens is this. We can break the vector into two parts. One part going this way, so that's the velocity in the x direction. And then we have one part going this way, the velocity for the sine. So this would be v cosine, and this would be the v initial sine. And now we're ready to do it. So now if you've taken physics already, you have those formulas that you used in physics. Very, very similar to what we're doing. We modify it a little bit though. So we have parametric equations for this. And these are the formulas you're going to need to memorize. So it's going to be x equals, so this is going to be distance. So distance is velocity times time. So it's going to be v initial cosine theta times time. And the y value, now this is what we have to take into account. Now, when you throw the ball, it doesn't keep going forever because gravity is pulling down. So in physics, you probably called it at squared or negative at squared. I'm not a fan of it, but this is what our text does. We put one, you called it 1/2 at squared. We took half of we're using English units, 32.2 feet per second squared for gravity. They call it 16, so they're rounding already. I'm not a fan of it, but we're going to stick with it. And so then we have the height. So this is the gravity pulling down. Then we have the ball moving up. But then don't forget, this ball started at a certain height. So we have to add that height onto the ball to start with. These are the two formulas you must memorize. So let's get started. So let's start with a question. So we'll call this question 1. So you hit a ball. So a ball is hit. And you hit it at 3 feet above the ground. with an initial speed, so initial speed of 150 feet per second. At an angle of 18 degrees. First part, write the parametric equations. That will describe this. All right, so we have those two formulas we're going to use. So now we're going to start off. So the x component is v cosine t. So it's going to be 150 cosine of 18 degrees. And then we're going to multiply this by t. So, we put t here like this. Just when we use our calculator, make sure we close the 18, close the parentheses. And the y value is going to be negative 16t squared, gravity pulling down, plus 150 sine 18, that's our 18 degrees, time, plus the height of the ball to start with, where you hit the ball, was at plus 3. So now, from these equations, we can figure out some things. So this x equation, okay, this equation is going to be how far the ball travels. And this is going to, this equation is going to say the max height of the ball. How high does the ball get? And also, when the ball lands, it'll tell us the time it takes for the ball to hit the ground. So that's the pieces I can get. So the basic story of this is going to be, I can graph this in two ways. Now, you can actually graph this straight with the parametrics, but if you don't have, till yesterday you didn't know what parametric graphing was, I can graph this in two parts. So the basic story is this. We have a graph. Somebody hit a baseball. It's going to go up and it's going to go down. This distance here, right, this is my goal, to find this distance, how far the ball went, and this is going to be the height of the ball. That's the basics. This x is going to be the distance. The height will be from the y. I'm going to use the time, though, to figure out the x value, which will also help me do the drawing. So what we can do is, in regular mode, I would start here. You start with y. So that's what we're going to start with. So punch this in your calculator under regular, y equals. So I'm going to get out of the, I'm going to change it back to function mode. And I'm just going to punch it in. So negative 16 x squared plus 150 sine of 18, close the parentheses. And instead of t, I'm going to be using x's for this, right? So plus 3, because I'm going to graph it as a regular graph. And then what I could do is I can use the table to figure out my window. All right, so let's see this. So I hit the ball at time 0. It's 3 feet off the ground. That's why there's a 3 there. And then, let's see what we got here. Negative 16 x squared plus 150 sine 18 x plus 3. I'm in the wrong mode, so I gotta fix that. Need to be in degree mode. This should be better. Much better. So it's at 3 feet. At 1 second, it's at 33 feet high. 2 seconds, 31 feet high. 3 seconds, it's in the ground. So this whole picture, so now I'm going to do two different graphs. So this is one graph. I'm going to get there in a second. But I'm going to use this here to get this graph. So it's going to be height and time. So I really need to only go to 3 seconds, it looks like, before it hit the ground. And it's only in the 30, so maybe I'll say 40 feet for my window. So my X would be from 0 to 3 seconds. It's quick. Counting by ones is fine. Y is from 0 to 40. And we're going to count by ones. It's fine. Hit graph. And that's the projectile. That's the ball only comparing height versus time. So that's around 3. And I can find the max height. Second calc maximum. So you want to get to the left, to the right. Enter. And something's wrong. Okay. Yeah, we're going to stop that. So we can calculate the maximum. And what happens is, let's just get rid of that. And it's all fixed. So it says this. The maximum height occurs at, time is, this X now is time. It's 1.4 seconds. 1.45 seconds. That's what that would be, at 1.45 seconds. And the max height is 36.57. So this height is 36.57, which is going to be the same height on this graph. So if I said, what's that max height? It's at 36.5 seconds. So let's find the time it takes for the ball to hit. So I'm going to go to y equals, and I'll graph the second ball, the second as 0, do my calc intersect, and I like to do intersect. You could do it by, find the zeros also, but I find this easier. And just do a guess. And it tells me it takes 2.96 seconds. So that's 3. So it takes 2.96 seconds for it to hit the ground. Hits the ground. All right. Now, I have an equation for X. I'm going to use this time, plug into X. So I go over here. X equals 150 cosine 18 times 2.96. Punch that in your calculator. See what you get. So I have a distance of 422.2, let's call it 2 places, 27 feet. So this ball goes 422.27 feet. How long does it take to get there? 2.96 seconds. How far away does it go? 422 feet. How tall does the ball get? 36.57 feet. So those are all the things you can answer. Now, there is another way to do it. You could go plug in straight into the parametrics. So if I change the mode, parametrics, and punch them in, now the reason why I'm doing them the other way though is because what if I don't have a calculator that has a parametric mode? I can still answer the questions. What if I'm not using, what if you're not using a calculator? What if you're just using some old tables from back in the day, how they used to do it? You can still crunch these things out. And if I change my window, I'm going to just go 0 to 3 seconds. T max is 3 because I know it only goes up to 3 seconds. I'm just going to call it 0 to 3. And remember all these things here. So max is 3. The Y maximum I need is 40. It fixed it from before, actually. So now when I hit graph, let's fix that. The only thing we forgot to fix, I apologize, was at our X max. Now we're doing distance. That X max should be like 430 feet. And if we hit graph now at this stage, we get, that's where it's going. And that's about it. So, thanks for watching. Have a nice night. Bye.